This video we are going to talk about the atom. First, when we remember the atom, we have to come to the mind to the structure of Rutherford atomic model. See, Rutherford done is alpha scattering experiment, and see that most of the particles deviated and most of the particle undeviated travel in a straight line. Okay, now if we plot the graph, number of scattering particles at the angle. Here see that the more we will get the rectangular hyperbola shape. We will get the rectangular hyperbola shape, and we see that only only one of the only one fewer deflected with a small angle, and very few are deflected with 180 degrees. 180 degrees. Okay, now this come to conclusion that most of the atom is empty. Most of the atom is empty. There is a mass located at the center. Next we will come at then we will come very important topic. Very important topic means closest approach. For closest approach, we are going to balance the energy. Energy means kinetic energy is balanced by potential energy. KQ1. Your charge is E electron and ZD is nucleus and R square. Okay, now from this they will ask the closest approach is directly or inversely proportional to mass. It is a neat question. From this we can write that closest approach is inversely proportional to root of the mass of a atom. Okay, now in this way we can write the relation. It is the neat question. Next we will see here assume here there is a nucleus and electron is revolving in a circular orbit. Electron is circular orbit. When an object is revolving in a circular orbit, there will be a development of centripetal force mu square by r. I said this in a dual nature of atom also. Mu square should be balanced by the Coulombic force of attraction or repulsion. Here Zd into E k by r square. From this we can write a kinetic energy. From this we can also write a radius. Radius is equal to mv square by kzd into E. Okay, now here r will get cancelled. Solving this we will get from that we also know that mvr is equal to nh by 2 pi. It is the conservation of angular momentum. It is angular momentum. Sometimes they will give I also correct. I is equal to mur is equal to nh by 2 pi. Okay, now from this we can calculate the radius by substituting velocity term in this equation. We can solve the radius from this. Okay, we will get radius as a 52.9 n square by z square. N square by z. Okay, n square by z picometer. Note this, it is a picometer. So velocity can be written 2.8 into 10 into z by n. Reverse is it z by n. From this kinetic energy total energy can be written as minus 13.6 square. It means kinetic energy means half mv square, negative of kinetic energy. So z square by n square will get the total energy formula. So okay, now next we will talk about here is the total energy, ratio of total energy, potential energy, kinetic energy. If you assume potential energy as 2x, then the kinetic energy will be x and the total energy will be x